Hey guys, today we're going to refresh our log laws and we'll try to solve this problem.
Yeah, so this problem looks pretty complicated at first, but we can see two things out of the bat, right?
We can see that these bases are the same, so we can try to group these together.
Yeah, exactly. So let's do that first. So we can move the log base x16 to the other side. And you can see that these two terms have the same base.
Yeah, and when you try to convert from linear to log, you'll understand that a negative or subtraction will become a division inside the log.
So what does this become? It becomes log x 16 divided by 8. Or rather, log base x 2. Okay, very good. Now, this is pretty tough, right? One x is the thing being taken the log of, and the other x is the base of the log. So let's try to move these two terms together to the other side.
And then we have to find a way to make sure they change their bases. Make them the same.
So one thing we can do, this fraction, it's not really fun, right? So let's multiply both sides by 6.
Yep.
Now we can use the change of base rule. So we can make this log equal to log base 2x and y log base 2, because if we do the change of base for both of these, log base 2 is very convenient. It kind of simplifies the 4 and the 2, and you'll see as log base 2 of 4 is 2.
Yes.
And this here, another 6, and change of base rule again, log base 2 of 2, and log base 2 of x. Let's move the 7 to the other side.
Yeah, for simplicity's sake.
So now you'll see that log base 2 4 becomes 2.
Yep.
Log base 2 of 2 becomes 1. Nice. And now you can sort of see a quadratic forming. Let's multiply both sides by log base 2 of x. So this is 3, 6 divided by 2 times log base 2x squared minus 6. And since we're multiplying log base 2 of
we're
x,
just getting rid of the denominator.
And minus 7 log base 2 of x. But now you see that here's a quadratic.
It is a quadratic, so let's substitute y for log base 2 of x.
So let y equal log base 2 of x. After that, we can just solve the quadratic.
Yep.
So 3y
squared minus 7y minus 6 equals 0.
Well, let's do some simple factoring.
And we'll come to the realization.
Yeah. So first off, you can probably do 3 times negative 6, and that's negative 18. So what two things sum together that become negative 7 multiplied together become negative 18?
How can we split this middle term to suit both other sides of the equation?
Well, it turns out that 3y squared minus 9y plus 2y minus 6 is perfect. So we have 3y, we can factor this, y minus 3 plus 2y minus 3. And this will become
3y plus 2 times y minus 3. However, we're given the restraint that x must be greater than 0. So, therefore, only one of these answers can work for the usual quadratic.
And that is y equals 3. The logarithm has to be positive. It cannot work if it's negative.
Yes.
So remember that y is log base 2x equals 3. So if we 2 to the power each side, and I'll do it right now, then since exponents and logarithms are inverse functions, they cancel out, and we end up with 2 to the power 3 or 8.
Yep, and the answer is 8. Thank you for listening.
Yes.